destination. I'd love to sit down there.
Okay.
And maybe come back to the office. Okay. Just that way you don't have to stay with us. So you get to sit up here all by yourself. That's rude. You got to keep your colleague company. Yeah, now I can see why people
Well, good afternoon, everyone. Thank you for joining this session, and I really look forward to hearing the speakers today. The name of the session is Transforming Cities and Countries with Digital Twins. Digital twins are reshaping urban and national planning by providing dynamic real-time representations of physical environments. In this session, we will look at the transformative potential of digital twin technology, featuring some projects for city management, planning and development using reality capture as well as digital twins. The session will provide valuable insights into how digital twins are transforming urban and national landscapes, fostering collaboration among stakeholders, and driving smarter, more resilient cities and countries. And what's really nice is when you think about digital twins, you can think about it from the perspective of it being a real small microcosm of a small area that has a small thing that has a digital twin versus looking at it from a much broader scale, in this case, cities and countries. And we've had several sessions in this conference related to digital twins. It means different things to different people quite often, but at the end of the day, the way this session is going to be structured is more talking about bigger cities, countries, and what a digital twin really means with respect to that. So really look forward to this session and listening to our speakers. We do have two speakers here today. We were supposed to have a third speaker, but they could not make it. And as a result, we will have Leif and Amar presenting. We'll do a panel discussion after that. We'll likely finish in about an hour, so I know the session's about an hour and a half, but just wanted to let you all know from a timing perspective, this will be about an hour. It is my pleasure to first invite Leif Johnson, and he's the Senior Solutions Manager for Cities at Bentley, and he is going to be presenting to us first. Thank you.
Thank you, Amar. So yes, my name is Leif Johnson. I'm with Bentley Systems and Senior Solutions Manager in cities. So what my role is really looking at digital solutions and enabling all aspects of the life cycle of the city's infrastructure. So what I was asked to do is just kind of talk a little bit about Bentley and one of the digital twin projects that we were involved in from a large scale. So part of the presentation really is around a large scale digital twin that focuses on the city and region of Pau in France. So first, a little bit about Bentley. Bentley, not the car company. So if you were looking for free giveaways of automobiles, we don't have that. But looking at what we do is we just celebrated our 40th anniversary this last year. And we have a rich legacy in engineering, design, and analysis applications, and a lot of expertise in that space. But now looking more towards enabling people to design, build, and construct more resilient and safe infrastructure and sustainable infrastructure, and using intelligent digital twins. So with that, looking at the entire life cycle, we have tools around the design, and the way I look at it is design feeds into an operational digital twin. So you have to be able to enable the entire life cycle to ensure that your digital twin stays evergreen. So from the design phase, being able to roll that design and communicate conceptual design ideas in context to the current state, the current as operated, if you use configuration management terms of the infrastructure, and then roll that design into more of the design phase or the construction phase to be able to simulate construction activities, scheduling, and all of that into operations. So first I thought I'd start a little bit about what is a digital twin. So from a purely academic standpoint, a digital twin is a digital representation of the physical world. So if you think about that, that can be quite overwhelming at face value, trying to replicate the physical world completely digitally. So if you think about kind of an example that I give is a digital twin doesn't need to be all encompassing. It could be just a few pieces of data brought together to be able to make decisions more in context, right? So we all know that we have a ton of data, right? Does anyone here have shortage of data? Yeah, I didn't think so. Does anyone have data that they can't access readily? I should see almost everybody's hand there. So the idea with a digital twin, I was at a conference last week that I thought was a really good definition of a digital twin, where it unlocks the value of your data. And quite simply put, if you're looking to leverage your data by layering that information and being able to have it accessible through a common interface that is easy to use, easy to understand, then you're starting to unlock the value and you're starting to be able to, starting to enable more informed and better decisions. So if we look at some of the layered information you can bring in, you're bringing in, geospatial data, you're bringing in you can bring in the subsurface data, sensor information, you can overlay that on like a reality model or a 3D model of your infrastructure. But you also have this underlying data layer that's not graphical, or well, it might be graphical, but you might have detailed engineering designs, you might have maintenance data around your infrastructure, you might have maintenance orders, service manuals, anything like that. So when you look at an asset, you can see that as well as sensors, what is the current temperature, pressure, operating state of the asset. So when I look at why do a digital twin, I think it's really important that I think a lot of people, in a lot of the conversations I've had recently around digital twins, is they have the concept, I need a digital twin. But until they look at the actual operational or the use cases that they're trying to support, what are you trying to accomplish with the digital twin? It's really important to identify that versus looking at it, like I said, back when I started, the definition of a digital representation of the physical world. Start to look at the use cases that you're trying to support. What is the data that you're trying to surface? What is these related pieces of information that you need to bring in context to each other to make better decisions? So when we look at the City of Pau, what they identified is they have this 10-year project, and I'll talk about this in a second. But some of the things that they identified that a digital twin would help enable is the transparency and collaboration with citizens. It's important when you're starting a big project to get community engagement, community buy-in and support of the project. And by being able to show the conceptual design in a way that is easy to understand and easy to consume, you're more likely to have better buy-in from the community. The other thing that they were faced is aging infrastructure. So they want to optimize what they have and be able to fit in and improve areas where they're going to get the most bang for the buck. When we talk about safety and resilient infrastructure, the idea is to make sure that you're looking at simulation of, what does a traffic situation look like? Do we have dangerous intersections? How do you visualize that? Being able to overlay accident information into your digital twin and see these hot spots. Being able to do a heat map to be able to make a decision of, this is a bad intersection. So I'm taking information from one system, overlaying it in another, and being able to visualize that and make a decision around safety. And then sustainability. So when we look at the City of Pau, the project, one of the big things that they were looking at is really trying to make sure that, okay, good work, is trying to make sure that they are achieving sustainability objectives. So one of the emphases of this 10-year project was to build in more green spaces, make the the pedestrian areas more visually appealing, bring in more greenery, plants and trees, and just make it a lot more appealing to support tourism. So this 10-year project, they began this renovation project to achieve, like I said, the sustainability objectives. They brought in traffic and mobility to improve the traffic throughput, the pedestrian areas, to make that safer. And when I was asked to pick a project around the large-scale digital twin, I was like, okay, well, large scale, we have statewide digital twin, you could have a global digital twin where you drill down to various facilities at various areas, and we've done that. But I thought City of Pau was a really good example of a large-scale digital twin. One, it covers 370 square kilometers of territory, so a fairly large area. And it also encompasses 31 different municipalities. So you have a wide variety of stakeholders that are leveraging the digital twin to visualize this 10-year project, this regional improvement. With that, not only do you have the municipalities, but now you bring in additional stakeholders within the architectural and engineering firms, the construction firms, and how do you get them to collaborate effectively? So that was kind of the scope of the project, was to work on this area and improve that area. The challenges that they identified was how do we leverage, or how do we convey the scope of this project to the citizens? How do we facilitate this community buy-in to ensure that there was support? Right? The better that you understand the end goal, the more likely you are to put up with traffic rerouting and things like that, because you understand the scope of the project, you understand the complexity of the project. The other thing was to how do we get our construction firms to work more collaboratively? How do we facilitate that back and forth communication effectively? Make sure we capture that, and make sure everyone's working off the same version of the drawing. How many times have you been on a project and you're looking at a drawing and you swear it's the latest and greatest, and you're actually looking at 2 versions back? When you look at the cost of change, or the cost cost of change, the further in the life cycle that change is identified, or that mistake is identified that you have to go back and fix, the more expensive it is. It becomes an exponential curve in cost to fix. The earlier you identify it through this collaboration, the cheaper it is to fix, right? As you start breaking ground, it becomes a lot more expensive to fix, right? And then if you break ground and you find out that there's utilities or something that you didn't identify ahead of time, the cost and the outage becomes a problem. The other thing that they wanted to do is the third main objective. So the first objective is community engagement. The second objective was collaboration, centralized portal. And the third objective was to do right first time construction. Right? So that gets into what I was just talking about, is making sure everyone's working off the same page of the information. So they identified the need to implement a digital twin. And the digital twin was going to give them the ability to, from the design phase, be able to design in context. So the first thing they did is they went and they took photographs of the area in varying resolutions depending on, if they were in town, higher resolution; if they were out of town, more forested areas, lower resolution, and then they crossed that to create a reality model. So that created your essentially your current state of the area. And by doing that, now they were facilitating designing in context. So now the engineering firms were able to design in the context of the current infrastructure. They were able to identify areas to work around, be able to fit in the updated road networks and traffic circles and pedestrian walkways, green spaces, and so on with that. The other thing that they did was they now surfaced this conceptual design to the community. So traditionally what they would do is they'd build their models and then they'd have to have artistic renderings, they'd outsource video production to show this conceptual design. It's a very costly and time-consuming process. And if you made a change, then you had to do it all over again because it wasn't real time and it wasn't dynamic. So by facilitating a digital twin, they were able to not only surface this conceptual design through this intuitive interface for the community, but they were able to produce these videos and this education to the community in a variety of forms themselves without having to outsource it. And because they were able to do it themselves, any changes or updates were able to be reflected pretty quickly in that process. And then the other thing was, now that they had everybody working in this common portal, they were able to see the scope of the project, they were able to have the various areas that they were working on, and they basically connect all the, not only the internal stakeholders, the departments, and also between the municipalities, but the engineering firms to make sure they were all working in this common environment. So looking at a couple basic metrics that they had, so they just looked at two simple things of what was the value that they got out of doing this initially. And the biggest thing was they had a 95% time savings in just finding information, right? Remember in the beginning I asked how many people have too much data or don't have data, don't have enough data? It's really finding it. You know, if you need a drawing or you need a specification or you need the last inspection report of an asset, you know, how much time do you have to get that? And not only do you have to get that one piece of information, but there's probably 2 or 3 other pieces of information that you have to track down to be able to put side by side so you can make a decision. Now by having that at your fingertips, by just selecting on the project or the asset and being able to drill down to that information is a lot easier. One thing I should mention, we hear a lot about the single source of truth. And I would argue that there is no single source of truth. That gives the impression that there's this massive system that houses all your data that you can then go into and it controls everything. There's a lot of systems and a lot of data silos that are necessary because they do some very specialized functions. You have your engineering document management system, you have your asset management system, you have your ERP system, you have your maintenance management system. All of these tools are not going to be replaced, but you need a window into that data, and you need to see that with the related information. So that's where, you know, I talked about the digital twin unlocks the value of your data. It enables you to see that data in context to make those more informed decisions. So when I first saw that 95%, I'm like, that's a metric we use when we talk about document management systems. You know, you're able to find the document easily. But now with a visual graphical interface, it's a lot quicker. So I thought that was very high when I started thinking about it, and I started thinking of the various departments and municipalities that were involved, and the various engineering companies that were involved, construction companies. I'm like, well, yeah, that can be very difficult. The more stakeholders you have, the more departments that are involved, the more siloed your data becomes. So by facilitating that common folder, the common portal, you know, you're really effectively reducing that massive amount of time that's spent looking for information. I mentioned that they spent a lot of money doing this video production to do community engagement. So just looking at the community engagement aspect, they were able to save, you know, $200,000 a year on these community engagement projects. So with that, now that they've taken the digital twin through the design and construction, they're now bringing in more and more operational use cases. So I said early on that a digital twin can return value very quickly by just bringing in a few pieces of data to be able to make those decisions and start to knock down those information silos, right? But now that they have the digital twin, they're starting to open this up to more and more departments. You know, traffic planning, events planning. You know, they have the subsurface data that they had, monitoring stormwater drainage, but now they're starting to bring in some other information of water, wastewater, electrical, fiber optic networks, and so on. They're also able to do additional projects. So now that they've shown and they've proved out the concept of designing in the context of the current state, they're able to surface this digital twin to facilitate that design, the conceptual and detailed design phase to additional projects that are coming online. So I just wanted to say that you know, the ending thought that I had is the digital twin grows. It's not a singular project. It's not something you do to accomplish a single project or a single single use case, it grows. It starts to become a way to do business, and the value of that digital twin grows as the data that you add to it enriches your digital twin. So with that, again, I'm with Bentley Systems, and we're in 612. So I appreciate it, and it was a pleasure getting a chance to talk about our work with the City of Pau.
Thank you, Leif. That was very interesting, and really look forward to a good panel discussion as well related to the work that was done in the City of Pau as well. Our next speaker is Aaron Morris, and he's from Woolpert. Welcome, Aaron.
All right. So first, I have to apologize. I understood that my digital twin was supposed to do this presentation, but it was stuck in an update. So you have to deal with the physical twin. The apology was for the joke. It's what happened when you use ChatGPT to kick off a presentation. All right. So, by the way, this is going to be the similar theme. I put some humor in here. But quick overview of what we're going to be talking about today. A little bit of background context. I mean, I think everyone who does a digital twin presentation puts in their definition, so I'm going to join them and do that same. Talk a little bit about applications and impact, but really what I want to talk about is the systems, the challenges of the systems and the technology that are coming online and what we're doing to see digital twins at this scale come to life. So I'll kick it off with this. So you heard of the spark bird? It's the bird that gets people who are into bird watching into it. Well, this was my spark digital twin. This is Cave Crawler. When I was a grad student in university, I spent my time working on this system. It's, as you can see, autonomous, mobile, subterranean robot. And when I say, following it, chasing it, I mean that in the most literal sense. Because this camera is a lot of what I spent 7 years doing, just following the robot, making sure it was doing what I programmed it to do. The thing to keep in mind is in the corner. So as you'll see, you kind of see it's a sort of a LiDAR buffer. Every time you make a rotation, a stream of LiDAR comes in and it goes out. So I'm sensing the world, I'm pulling in data, and then that data is being brought into models of the world. So, and as you can see, there's arrows sticking off the side of the wall. So it interprets barriers, and it's kind of creating like a magnetic field to repel the vehicle from where it's wanting to drive. And you can see the steering angle visual as well. So in robotics, the high-level architectural view is sense, plan, act. Sense the world, use a model to do your planning, and take action in the world. And little did I know, that was the beginning of pretty much a life and a career in digital twins. I was doing that work in 2004 at Carnegie Mellon University. That would go on to effectively digital twins of roads and highways. As part of some of the early autonomous vehicle work, and coming out of that, did a startup company to do this. This is LiDAR feature extraction, which you're all about today. Looking at paint lines, signs, overhead infrastructure. That company led to the acquisition to another company called Autodesk in the product line Recap. Again, design world, built world, but to make it a digital twin, you need sensor data. So me and the team created kind of this first product line to start bringing the design portfolio of Autodesk into this idea of digital twin. And then later on we left to do another company very similar to that, but now backed by the sort of volume of data coming in, particularly fueled by autonomous vehicles, to then take this really rich data, turn it into these information products, and provide it to all kinds of different stakeholders. And finally, here at Woolpert, which phenomenal company, been here just over a year or so, and you talk about sensing, if you're data science and AI, it is a playground, phenomenal place to be. So anyway, that's a lot of context coming into what theme of this talk is about digital twins. All right, I'm going to start my definition of what a digital twin is not, since that seems to be kind of a good place to get people on level ground. So what it is not is a snapshot in time. It is not an as-built model, it's not a BIM, it's not a photograph, it's not a video. Those are all stationary moments in time. Without that sensing and update, it's not a digital twin. Similarly, if I've got streams of data and they're producing graphs and plots, and I'm seeing, what a thermal sensor is reporting from a building, that's also not a digital twin, right? There's no spatial context to that, there's no model, and so the culmination of digital twin is that model with the data and an update. This is the definition if you go to Wikipedia. I'm not sure who was the author, but the way I like to frame this or think about this one is, it identifies the purposes, which really kind of really push forward the notion of it's a model. So they use it for simulation, you use it for integration, testing, monitoring. So it is, to some degree, alive. And just like my simple robot analogy, the elements that I like to think about in terms of digital twin, there's the physical twin, the digital version, which is the model, and the data that interacts in between the two. I would like to call out something that I think is interesting, which is, if you look at the evolution of the digital twin, its history comes out of NASA and aerospace, looking, when you're sending a system into an environment where it's only got one shot, the only way to really test it is to have the digital version and simulate, right? So obviously that's a natural place for it to start. And so the digital twin is built, or has originated from the built environment, which makes sense. Like if you're designing something, you've got an as-built content, that's a great starting point for your model. It also spans the things, obviously infrastructure, buildings, even the services that we do. Anything that can be constructed from a model, can be put into this context. It's very interesting though when you start talking about cities and beyond, because these are not things, I don't design how a tree is. I don't design a mountain, right? But yet, we're using data to create the models and to create these digital twins around them. So it's an interesting leap to take this term, which has been affiliated with physical things that we make, and bring it into all things that we can observe. Sample use case. So a little plug, a colleague of mine, hopefully you guys don't leave this, but if we get enough time left over, you can go over. So we've been involved with the virtual Singapore project, which is, again, the project, city, country, digital twin. We're involved in the aerial capture, both from the LiDAR and the imagery, and it's a test bed for all kinds of applications, use cases. Here are the images here, so they're simulating what, where they place solar cells for energy. They're looking at mobility options. There's all kinds of playground for people who want to get in and use this kind of real-time data and models to understand the world, provide insights. The one that I particularly like is one I spent years and years doing, which is positive train control. For those unfamiliar, it's a safety standard for the rail industry. Effectively, you have a digital representation of track and everything assets around the track, and if the train is moving along and it's approaching a certain critical asset too fast, it'll issue an alert, and if the engineer doesn't respond to it, it goes ahead and takes control. Perfect example. However, again, there's a need to update. So the types of assets you're looking at, tracks, switches, signals, derailleurs, those kinds of things. There's a handful of other assets. We were doing this project for a program like 5 years plus with Kansas City, now part of Canadian Pacific through CPKC. And so one thought experiment, and I'll do this again, is to really start to look at the scale, because another important thing kind of forgot to mention is as you go from these, physical man-made to the world, the scale just amplifies. And so, even in this man-made environment, Kansas City Southern had about 2,000-ish miles of track, and across that, 18,000 assets, right? If you were to inspect each of those assets, and they all needed to be inspected at some point, and we're not talking about physically going after, but even if you spend 5 minutes in a digital context finding it, assessing it, you're looking at 9 months plus to go through and do an audit of their entire inventory. Through this process that we created, we did it in a few months or less. We did that at 99% accuracy. So one of my assertions here, and I'll talk about in a minute, is that we built AI technologies to enable the creation. In fact, I think AI is a foundation to the enablement of digital twins at this scale. Another example that I like to talk about is the utility industry. Been doing transmission lines for a while, but distribution is very hard. They're everywhere. Some interesting statistics on the utility space. 70% of the lines and transformers are more than 25 years old. And there are 6.3 million miles of lines and grids out in just the US. 25 years old, issues are going to start to occur. What kind of issues? Leaning poles, too much sag, issues with the things that are attached to them. And then you've got the natural world encroaching. You've got trees and vegetation. You've got the built world encroaching. You've got roads and building stuff getting involved. But with the digital twins and monitors, these changes, the impacts are profound. Reduced downtime and outages, lower maintenance costs, improved grid reliability and safety, and high customer satisfaction. Who doesn't want a power grid with those characteristics? But again, we'll look at numbers. 6.3 million miles, let's just say on average you can do 30 minutes of traverse per mile to inspect and do assessments across all that. And let's assume it's 19, 20 hours in a typical work year. You're looking at a substantial labor force going out there and doing nothing but looking at wires all day long, every day, as a job, right? That's rough. Now, maybe this is an opportunity. I am an entrepreneur, so after this, I'm looking for investors and a potential opportunity to do the Uber for power lines and inspection called Poles and Wires for Hire. Okay, obviously that's ridiculous. But if you're trying to do these things at scale, right? This is one of our airborne LiDAR systems, train mapper, 6,500 feet, going 150 miles an hour. There are transmission lines there. Very hard to see. Maybe this perspective, but even then, if I'm responsible for monitoring these things, assessing them, reporting them, it's very difficult to do that assessment with what you don't see. So this brings us to what we feel is two major challenges with doing digital twins at scale. One, if you're doing city size or larger, and you're maintaining the frequency, you are going to need very dense data very quickly. And the second, which we already talked about in terms of what we do with positive pain control, if you're getting a lot of data, and talking about data, you need tools to help you manage and use that data effectively. So here's what we have been doing. So let's talk about dense data very quickly. Now, I'm going to give you some previews of things that we're doing. Just know that their previews will, who knows where it goes, but just to kind of safeguard against things they're showed. So within Woolpert, we kicked off what we call the High Point Density LiDAR HPDL program. Let me give you context for what we're into. So to do power line mapping from airborne, you're looking at something like this. You're flying at 670 meters, and you're 130 or 150 miles per hour, right? That image I showed you before, that was performed what we call the standard, so about 2,000 meters, traveling about 150 84 miles an hour. Where we're going, what we want to do is this. This is our HPDL. So we are at over 3,000 meters, traveling over 200 miles an hour, and we're collecting more data than any of these other options. So our goal is higher, faster, and denser. So let's bring up that image. So this is what's the standard. Let me show you what we're doing with HPDL. Can we see the transmission line now? Here's another example. Can we see the transmission, maybe some of the distribution? Maybe. We squint hard enough. Here's HPDL. Give you a preview. So now processing at scale. So when we came in, me and the team came into Woolpert, we were working at city scale and at the ground. So we built foundational models to look at cities, to look at roads, to look at rail. We looked at both LiDAR and imagery, did feature extraction, curves, signs, and we learned a lot along the way. As it turns out, when we get into this topic of AI, we think data is perfect. Data is not perfect. There's all kinds of nuances about the data and the environment that you are capturing the data in, that you're just feeding it blindly to models to train off of. You're going to get some odd results. Also, the environment's not perfect. The models that you see out in the real world are not exactly what the idealistic intent of them are. So you're dealing with all of that, plus you're still dealing with people at the end of the day. People who are working these, training these models, putting their own biases into the system. So there's a lot when it comes to working with data, training these models, and doing AI. But critical. So within this HPDL, we are doing AI at every scale. We're doing it in pre-production to make sure that data comes in, to handle this sort of gravity of points that are streaming into our systems, doing the cleaning, removing the things that are irrelevant to our processing, relevant to our customers, and necessary for us. And we're doing things that are higher value. We're doing classification, and ultimately going into feature extraction, which really, at the end of the day, is what's driving the digital twin. I like to give this example because it was earth-shattering to me the first time. So can you spot the ground issue? Because a lot of, when you're looking at just refinement or looking at points that are related to the ground, you're removing piles of data, or piles that aren't the ground, or you're dealing with pits, or you're dealing with depths. You can train systems to find those and recommend an approach to remove and clean it up. So these are the kinds of things that we are working on to enable digital twin. And so, bringing it back up, we are like all in on HPDL and looking at the changes that you can't normally see or wouldn't have previously been able to see from the sky. A few examples: vegetation, looking at buildings, edge pavement, terrain models, and hydrology. When you combine these data sets and leverage the full output of what we're providing, it can be very interesting. So, conclusion. Digital twins are transformative, especially at the city scale and above, but data and AI are required to make them operate efficiently at scale. As we know, there's complication with all this, and that you will need tools like AI and machine learning to process all this, work out the issues, and there's a lot of people. Oh, there we go. There's no place to do it better right now, and if you want to connect with the digital self, my digital self, the QR code is right there. So thank you.
Thank you so much, Aaron. That was a really interesting presentation as well. So we're going to get into a panel discussion. I'll probably just stand here and answer questions if that's okay. And folks in the audience, if you have a question, please feel free to stand up to get to one of these mics, and feel free to ask questions. I'll ask the first one, and then we can, if anybody wants to ask a question, please come by to the mics as well. So let me start with you, Leif. So a great presentation, a great example of a city which is actually actively using this digital twin. From your perspective, there are, the way you can see that there are two parts to it, right? The data collection, which is also sort of a living piece, but there's also the creation of that initial digital twin. So what kind of timeline is, for say a large scale like a city, would you consider where an initial digital twin can be set up? How much time would it take, assuming you have the data you need?
That's a good question. It's one that we've actually talked about, how to give a good answer to that, because one of the answers I heard from one of my colleagues is a response of how long is a piece of string, and it's like, well, that's not a really satisfying answer. But I think that as I identified early on, is if you identify the use case that you're trying to support. If you start there with the data that you're trying to elevate visibility of, a digital twin can be created in a matter of weeks with data that you already have. That's the thing is, when I talk to various cities and airports and that are looking to implement a digital twin, they already have the data. Like I said, I'd be shocked if anyone said that they don't have enough data. But being able to visualize that, being able to contextualize that is critical. So, the short answer is I can provide something that will give you insights in literally a matter of weeks, if not, and we've even done things that are smaller scale that were done in a matter of hours. But it's just a matter of making that connection to data.
Yeah, and you bring up a great point also in terms of how the data makes is such a big factor, right? Having an access to that data as well. And in your experience with this project, how did this the city or the municipalities or other parts of the folks in the city help with getting the data ready for a digital twin? Any experiences that you had that you could share with the team?
Yeah, I'm going to take a different slant on that, because one of the things that I found when people are looking at bringing data in, it's like, well, we need to clean up our data first. I'm like, well, you could go into the old adage, garbage in, garbage out. I don't really take that approach because of the experience I've had. When you start bringing data in and you're starting to add that visibility, now you're able to identify where you have holes or gaps. One case in point, I was working for a user in Canada that was bringing in all their asset information for a refinery. And they have relationships between their assets. They're called tags. Tag numbers identify where the asset is. And those are usually called out on the drawing. And as they brought their data in, they wanted to clean it up. Finally convinced them to just put the data in. And then through reporting and that visibility that we provided, they were then be able to very quickly identify, hey, we're missing a lot of drawings, that are just not here. Where if they were trying to do that before loading that and providing that visibility, it would have taken way too long. So I think those connections can be made very quickly. Most systems today have APIs to bring that data in. I'm not suggesting that you're going to bring every possible piece of information, but at least you're providing visibility that exists. You can make these decisions without having to know the ins and outs of these other data silos.
And I think another great point I think you made also was that once data is in a digital twin, not only do you know what you have, but you also know what you don't have, and more importantly, what you need as well. So that's fantastic. Okay, so Aaron, I have a couple of questions for you, and in the interest of full disclosure, Aaron and I work at Woolpert, and I've been at Woolpert for a little over 3 months, so I'm relatively new to Woolpert. He's been there for a year, but we've already started working a lot together as well. So, Aaron, in terms of I like how you started off with your definition of digital twin and what it is not. And then you did bring the buzzword of AI as well. So you brought both the buzzwords in AI and digital twin. Well done. But I wanted to ask you from your perspective, how do we, when we're thinking about digital twin and you think of how AI helps a digital twin, how do you, when someone's trying to, again, start a digital twin project, any suggestions you have in how they would incorporate the physical world, your digital twin of it and the data, and then the application of AI towards that, creating of the digital twin? So any suggestions on how someone could start a project like that?
Absolutely. First off, I think for future, I might hand out bingo cards. So AI, digital twin, and we'll liven the audience up a little bit. But in terms of how to start, so I've got a really good, I'm sure some of the people who've been long enough, they're so tired of this story, but it's a really good example. Our City of Pittsburgh, many years ago when we really got into making this platform, the City of Pittsburgh was the ground zero for autonomous vehicle testing. We had partnerships, so great real-time data source. And we were looking to find avenues to take this data, turn it into digital twins, sell information to a variety of different stakeholders. We started working on a project with City of Pittsburgh, and we were actually in a discussion, and this GIS engineer comes in and is like, hey, can you guys find streetlights? And we were like, sure, we can do that. Why? And they're like, well, and again, this was early on the rollout of 5G. They're like, well, Crown Castle, who kind of works ATD Verizon rolling out these assets, they're like, hey, they want to permit these things, do these small cell installations, so they need to know where they're at, and they want a license. So we don't have a good up-to-date database. And we're like, wow, okay, well, it's better than nothing. Why don't you send us a database, and then we will, start training classifiers to identify streetlights and produce a map. I'm like, okay. So the next day, I get an email with an Excel spreadsheet on it, and in the Excel spreadsheet it says streetlight, and the location right beside that was, if it had anything at all, was Forbes Avenue. Like, okay, all right. We're starting from ground zero, effectively. I think the nice thing about starting a digital twin is you can use any sort of existing design context. I mean, back in my Autodesk days, like, as design is never as built, so you can't rely on it as to be ground truth, but it can serve as a nice starting point for that. Again, I use technology a lot, but to be honest with you, again, you can get started with very manual means, physical data collection, inspection, anything that really starts that cycle in. Having said that, there is a lot of data out there in the world, a lot of companies now that are producing, so to get started, I don't think you have to go very far, but coming in, working with companies like Woolpert or smaller providers, and I think your point was really well taken. Application specific. Like, it's hard to say, I need a digital twin. I'm like, okay, what is it you actually need? And I think being very focused, you can get to a solution very quickly if you know what your aim is.
Absolutely, that's a very valid point in terms of what do you need it for, right? And where are you going to go with it to decide what you can. It's not only about just the source data, but what are you going to use it for as well. So, great points. Any questions from the audience?
Thank you, Susan. Ed Carroll from Toronto, Ohio. Along the lines of what a city or business does not have when it comes to data sets. I'm wondering, where you see the digital twin technology going to enhance, say, preparedness. Oftentimes, emergency managers do tabletop exercises. I'm curious if you think this technology can enable better decision making, like literally creating scenarios like a forest fire or a flood, so that the decision makers can see what's possibly real given their own environment.
Yeah, I think that's a great question. One of the projects that we're working on, we're creating a digital twin in the city of Dublin, and we're working closely with the fire department. And this is actually one of the use cases that's near and dear to my heart, which is why I jumped in. So I apologize because I'm a retired firefighter. I was with the department for many years. What they're doing is now that they built the digital twin, which is basically they took built a reality model of the 3D representation of the city, the structures, the buildings. They tied in CCTV footage to this, and they're doing pre-incident planning and for various emergency scenarios. So they're using the digital twin to visualize and do the planning, and they're saving, I think they said 85% faster in their pre-incident planning efforts. So you have the planning aspect, so you're going through, you can see where what buildings are close to each other, where you would want to go if it's a fire incident, where you might need to go defensive because of the location of the structures, things like that. But they're also using it to be able to track from an incident command standpoint. So now you do have an incident, you have firefighters on scene, now you can track the location, where the firefighters are, where you have different teams, where you need to reallocate resources based on how the incident is going, ostensibly. So I see there's a lot of activity or use cases around the planning standpoint, as well as the activities. Another case that you mentioned, Louisiana, the state is using the digital twin to do flood simulation. So they're taking their digital twin and they're able to run flood simulation and what that's going to entail. So from your standpoint, citizen safety is a really big return on your investment of spending the time to build the digital twin. And as I said, as you build this, you'll start to identify more and more use cases that you can support with that digital twin. You may start over here, but then down the road you're like, oh, hey, you have that? Let's bring in this information, bring in this data, or surface this to additional departments like planning, traffic scenarios. If there's an accident, you need to reroute traffic, you have to have the ability to simulate that very quickly to see what's going to happen.
Yeah, I'll actually pick up from there. This career, you want to call it, in this world has never ceased to amaze me. The things that you get into in the City of Pittsburgh, I remember all the time in that same meeting, they said, oh my gosh, I only wish you were here when we replaced our garbage cans. Because they were doing these like smart new garbage cans. They were trying to remove all the old ones. We had no idea. We were just thrown out into the world and having to figure out where to go. Again, simulation, planning, emergency response. I think the applications are endless when it comes to that. What has always got me very interested in it does tell into that, we don't know what we don't know. One thing that's very compelling about the digital twin is the temporal element. The idea that I am collecting data over time and I can start to look at trends that occur over time which you're not going to see. So the word predictive analysis, the idea that I can start to forecast things that I have no model for. I can start to see, well, I know this thing's not looking good, and all I need to do is one or two incidents of a failure to see, oh, that trend indicates a critical failure, we can avoid it. So again, I've done tons of the different types of infrastructure projects with the idea that if you can capture it on a recurring basis, even if it's not the thing that you're initially starting out for, these trends can provide visibility into patterns that allow you to predict the future in a way we can't do today.
Fantastic, great response. Any other questions from the audience?
Got one?
Oh, sorry.
No problem. We talk a lot about smart cities and applying these things in urban areas. I live in Wyoming and I work in Wyoming, and I'm curious what your thoughts are on, can we do these things as smart villages or smart rural places and have, digital twins that help, say, a gateway community to Yellowstone National Park better manage, the influx of people during the summer, or a place again in Wyoming like Kemmer, Wyoming, where they're going to build a small-scale nuclear reactor to replace a coal-fired power plant, and how that's going to change that tiny little place. Curious about your thoughts on that, and if there's any sort of unique social issues with when you have a really small place and all of a sudden these people feel like they're under a microscope when you're sensing everything they do.
All right, so I love that, and I do think one of the things that is happening is, being in this industry for a while, is you start to see the accessibility of the technologies reaching a greater audience, and I think it's, to me personally, very exciting to see, again, the idea of a digital twin in a local community, dealing with an issue that, most of us probably would not care about, but it's critical to them. And then another fun fact about me, my family owns a bowling alley, and so I sit there when I go visit and I say, wow, what can I do to be a more effective business? And because here's another thing about the digital twin that was thrown up on my slide, is it doesn't necessarily have to be an object in the world. Like, our business processes can also be modeled and simulated. So I think, to answer your question, is that I think if it's a technology kind of approach, but I do think there's more tools, there's more training, there's more opportunity to get into it, but it will take the drive of somebody saying, you know what, there's a better way to do it. But I think, again, now's never been better in terms of trying these things out.
Yeah, I think one of the things that you mentioned national parks, right? And I used to live in Estes Park, which is gateway to Rocky Mountain National Park, just a few short miles away from here. And when COVID hit, as that was winding down, the staycations became the thing, and the amount of traffic going through town was ridiculous. I couldn't get anywhere during the summer anymore, and people were, cars were stacked up out the park for miles. So when we talk about smart cities or what does that mean, the first thing is, well, you're bringing in sensors, to actively monitor, is there parking? So now you have that feedback before you ever go. Is there parking available? You see that in parking garages. I'm seeing that now in airports. Is there a stall open? Which I'm like, okay, maybe that's a little too far for me, but and then you add the privacy concerns of what are you seeing? Your car is parked somewhere, and they can monitor that. I don't know how to answer the privacy aspect, but I do know that as you start to collect sensor data, you're able to make more informed decisions and surface that to a wider audience, such as use cases like parking, or being able to get feedback on your phone that, hey, my parking meter's about to run out, things like that. So.
Great. Thanks for the question. Thank you for the responses as well. I was thinking as you were talking through this that, with digital twin, in terms of what we have today, and what we can do at such a large scale with cities, countries, I would think, in terms of visualization and processing power that we have today compared to even 5 years ago is, there's a huge difference. It's only going to get better over time. So again, this is maybe to both of you, just comment on what you see right now and what you see going into the future for having more, the more you can do with the digital twin makes it more of a tool that people will want. And visualization and processing power will soon play a big role in that as well. So, any comments on that?
I think we're just scratching the surface of what we can do. You know, my company just acquired CTM for the visualization aspect and being able to stream large amounts of data very, very quickly with the digital twin. I'm going to go back to an analogy I used for work for a cat company, and we were